Hi everyone. Today I'm back with this video tutorial about Midas. I'll be working on this simply supported beam as shown in the screen. The main purpose of this video will be to get a better understanding of load cases and load combinations in Midas Civil. So there are 9 steps of doing an analysis of this beam. The first one is to create a project in Midas, and then you'll simply have to define material of the beam and also the section property. We'll draw nodes and then connect them by elements. We will assign boundary supports. The sixth step will be to define load cases and also load combinations. We will assign loads, including self-weight of the beam. And after doing all that, we will perform the analysis and look at bending moment diagram, shear force diagram, and reactions. So let's dive into Midas. This is Midas, and the first step, as I already mentioned, is to create a project, which I've done that already. Now I will define material. I'm going to use steel material, which is A70950, and I'll click OK. Also define section property. As you can see, I'm told to use W21 by 44. So I will use AISC W21 by 44 and click on OK. Now I'll go to node element, start my beam at the origin. I will create 2 elements, each 15 feet long, because my beam length is 30 and I have a point load in the middle, so I need a node in the middle. I'll click apply. Now you can see I have 3 nodes. I will click at create elements, select my material and section, then click here, click at these nodes, and now I have my beam here. Next step will be to go to boundary and define support. I have a pin support at the left end. I will select that node and apply. For the other end, I will make it roller. So the X, I will make it free to move along X direction. So I will only restrain dy and dz, and I will select my node and apply. Now as we talked before, I will have to define load cases. So go to load, go to static load cases. The first one will be dead load, and select the type is dead load and add. Second will be live load, which will be a live load type, and click on add and close. And we'll go to results, load combination. If you're designing a bridge or some other project, there are a couple of other options that you can auto-generate using this auto-generation tool. But for now, since I'm using 2 specific load combinations, one from ACI and another from Masto, I will do it manually and show you how it's actually done. If you click on the spreadsheet form and name the first one load combination 1 ACI, and that load will be 1.2 factor and live load will be 1.6, and the other one is strength 1 Masto. So this is 1.25 and 1.75. I'm not gonna fill any description or anything. I'll just close out. Now we defined load case. We already defined load combination. Now we will assign loads. And the first thing that we should do is assign self-weight. I will put it in dead load. So in the G direction, I will make it -1 and add, and I will just close. If you go to works, now you can see it here. This is the static lowercase 1 dead load, which is the self weight. And I will add the live load in the middle. I have a live load of 10 kips in the middle, and let's add that. To add that, I will go to nodal loads, make it live load, -10, select that node, apply. I will go to the node and element view, just to make it looks nice. And I will close out of it. Now, as you can see, I have uniformly distributed loads. The first one is live load 0.75. Let's do that. Go to element, go to live load, and it's throughout the beam, and it's 0.75 negative. That is, it is acting downwards. So I will select both of these elements. So 0 is at the left and 1 is at the other end of the selection, and I will apply. I will do similar for dead load, which is 0.67. And I will select them again and apply, and I will close. Now you can see in dead load, I have self weight, I have beam loads. You can display it. That's 0.67, rounding to 0.7. Up here, I have point load in the middle and uniformly distributed load throughout the beam. Okay, and now we can go to analysis and perform analysis. Before that, I will have to save it, so I will just save here. And it didn't take more than a second. So let's take a look at the results. You can look at the reactions. And to look at the reactions, you'll have to select the lowercase or combination. And let's take a look at the ACI and select FG. Click on the legends, values, apply. The applied load and reactions are overlapping, so I will just undisplay loads, and then you can see I have a reaction of 38.9. You can also look at the ASTO reaction, which is slightly higher, 41.8. And I will just close out of this. And to look at this shear force and bending moment diagram, go to forces, beam diagrams, select the load combination or load case that you want to see. And for now, I will look at moment Y. I need the exact value. I have a legend and value and apply. So you can see this is the bending moment diagram due to ASTO. To look at the ACI, select that and click on apply. Also to look at the shear force diagram, click on FG, apply. Oops. Oh, yeah, that's only dead load. That's why I couldn't see any effect of the point load in the middle. So it's curious. Yeah, select ACI. Yeah, I was looking for this bump or the break here. Similarly, for ASTO, apply. And that's pretty much. As I said earlier, the main goal of this video was to get familiarized with load cases and load combinations. Hope it cleared everything up. And if you have any questions, let me know. and I'll see you in the next video. Thank you.